Hi, my name is Meredith Renaud, and this is my lab report for Physics 2212, Section xo7, Lab 2, Charge Tapes 2. In this lab, we will focus on expanding Lab 1 by focusing on distributed charges instead of just single-point charges. The main physics principles are the same, except that we will be focusing on distributed charge versus single point charge, and the results of the experiment are still the same, in which the charge of the tape is positive, and for the tape to float, the gravitational force must be equal to the electric force on it. Similarly to the last lab, in order to determine the sign of the charge of the tape, I released the U-tape from the desk and realized it was attracted to my hand. It was also attracted to the textbook, and it was attracted to the negatively charged plastic pen, so I knew that the U-tape was positive. In order to determine the magnitude, I first found the gravitational force, in which I multiplied the mass by the gravitational constant, and since the net force is 0, the magnitude of the gravitational force must be equal to the electric force. Since we know that the force equals 1 over 4 pi epsilon naught times charge squared over distance squared, we get that the charge is equal to the square root of F times 1 over 4 pi epsilon naught times d squared. The length of one piece of tape was 0.2 meters, the mass of one piece of tape was 0.002 kilograms, the distance between the two tapes when one began to float was 0.14 meters, the gravitational force on the floating piece of tape was 0.1962, or 1.96 e to the negative 2, and the magnitude of the electric force on the floating tape was 0.0196216, or 1.96 e to the negative 2. I'll further explain these calculations in the coding slide. The coding slide is where you see the major differences between Lab 1 and this lab. You'll see in the representation of the code there are several different elements. The red elements represent the top tape, while the blue represents the bottom tape. The green arrows facing up represent the force from the blue tape onto the top tape, while the white arrow represents the electrical force, and the yellow tape represents the gravitational force. If you look closely on the code to the right, you'll see how I calculated each of these things using the forces and the magnitudes. In order for the forces to be the same for the electric force and the gravitational force, I had to play around with the charge a lot in order for those magnitudes to be equal. The magnitude of the charge on one piece of tape that I finally calculated was 5.655 e to the negative 8. And what assumptions, approximations, or idealizations did I have to make to determine approximately the amount of charge on a floating tape? I had to ignore air resistance on a moving object, and I also had to assume that each U-tape had about the same amount of charge evenly distributed along the length of the tape. Finally, let's compare Lab 1 with Lab 2. What if we had modeled each of the tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get with use your experimental data to produce a point charge model to the value you got with your line charge model. If I'd modeled the tapes as a single point charges, the data collected would be quite different due to the lack of distribution of charge. When the experiment was done in the point charge model, the estimated value of the charge was 6.53 e to the negative 9, while the estimated charge value of the point charge model was 5.655 e to the negative 5. And why do these estimates differ, and which value is more likely to be closer to the real value, and why? These estimates differ, for sure, and the line charge model is more likely to be closer to the real value because realistically, the electrons and protons are spread amongst an object, not in one singular spot. So line charge model represents a more accurate representation of the interactions of charges in everyday objects.